I think that will be a cool one to show some integration with all of the other Azure components it can, it can integrate with.
We love Azure Functions, so that's brilliant. We also made a little switch with plushies. So we are joined by Brady, our open source mascot, and Octocat got a friend, Octocat. Enough with goofing around, I think. We are running a little bit late, I guess. So let's take a look at the next session. So Roel, what is the next session about?
Yep. So next up we have David Pasdera, who's telling us all about flexing your Azure muscle with Bicep. And Bicep is a really cool new technology, but I don't want to take his space. So let's introduce him.
Are you there?
Yes. Yes.
Awesome.
There he is with a cool.
This is the thing about life, right? Like, oh well.
He's not showing up.
Oh gosh, I'm live.
There he is.
Yes.
Cool. Welcome.
Okay.
Hey, David.
Thank you. Thank you. I hope you can hear me well.
I can. Yes.
Perfect. So, greetings from Norway. Snowy but rainy a bit. And welcome to my session that surprisingly won't be about fitness. And I should probably share some content as well.
Yes, please.
Yes, please. But it will be about a very interesting project that can help you with adopting infrastructure as code practice on Azure. Just let me double check that I can see Stack as well. Yes, perfect. So my name is David Pasdera, and I work in Microsoft Norway as a senior cloud solution architect. I've been running many projects where large customers were really trying hard to adopt infrastructure as code practice, predominantly using ARM templates. But also be it Pulumi or Terraform. And of course, we all can agree that authoring and using ARM templates is hard. JSON as a sort of foundational language is very verbose. It requires you to be very mindful about columns, about the precise syntax and the structure. So the team around Azure Resource Manager, they kicked off a new project they are now calling Bicep. Why Bicep? Because we have ARM. So I actually like the name. There was a poll about what the future name could be, but for now it's Bicep. And so we will explore what the Bicep is, what it is not, and we will walk through from a simple examples going to more advanced workflow, something I do when I'm working on Bicep files development, and in the end we will look into some automation through GitHub Actions and the roadmap that is also publicly available for anybody to see. So the project Bicep, its goal is to create a new DSL language that would be sitting on top of a resource manager templates, and as such, it is an abstraction. So it is not trying to compete with ARM. It is actually something that sits on top, as you can see in the diagram. And when you want to deploy your Bicep code, you actually need to compile it or transpile it, depends how you want to call it, into a proper ARM template. And then you can use your regular tools like AZCLI or PowerShell module to run the deployment. So it's in this way, it's really an abstraction, and we can think about ARM JSON as an intermediate language from that perspective. So you still require your standard tools to do the actual deployment, but what is exciting is that we will look how simplified the syntax and the use of Bicep language is. So as I mentioned, there are several goals that this project has. So reduce current pain. That's probably goal number one, and help people with adopting infrastructure as code that is in the ARM JSON world not very easy, and you need to be quite skilled to actually do that. Since it's a transparent abstraction, it means that it can leverage all existing benefits from the platform. It also means that anything that you can do in ARM language, ARM JSON language, you can do in Bicep. There are a few exceptions, and we will look at the roadmap, what is available currently in 0.2 version, and what will be available hopefully beginning of next quarter in 0.3. But that's the whole idea. All the functions that are available in ARM language, they are currently also, with few exceptions, available in Bicep. But the second most important goal is to provide modularity. You know that when you begin with ARM templates, you start with adding more resources and maybe parameters to one single file. And in the end, you can end up with hundreds of lines of code. So there is currently in ARM a possibility to sort of detach some components, and you can use so-called linked templates. So having the parts of your code in a separate files. But it has a few caveats. First of all, you need to stage those linked templates to some place where the ARM API would be able to reach out and pick them up for the deployment. Bicep is actually reducing this pain in form of a new capability called modules. It's also good to talk about what are not goals for the language. So it's not something that would override all other great possibilities that are available. Bicep is not trying to compete with Terraform. Its primary focus is Azure, and it will, I can't say never say never, but I don't believe it will be used to deploy to AWS or GCP any time in the future. But there might be some additional capabilities, maybe around Kubernetes, for instance. But it's really an abstraction for ARM JSON, and since ARM cannot provide or deploy to any other sort of providers, then of course the focus is clear. It's also not a general purpose language. It's really a DSL that should abstract the complexity and help you with writing your infrastructure as code for Azure. And it's even though the syntax is of course new, it's reusing a lot of similar constructs that you will actually find very familiar from other languages. So today we are on version 0.2, and it came with a lot of great capabilities. First of all, support for tooling. So the primary tool for Bicep today is Visual Studio Code. It's not a surprise because it's still ranked as the most popular IDE, and it has an extension that now in this new version provides full Intellisense and code formatting, and so we will actually see that in the demos. It also provides the ability to split your code base into those modules that I briefly mentioned. And it also introduces something called scopes. So a possibility to deploy to both subscriptions and resource group level in one single template, for instance. It's also good to remember that it's still an experimental language that is not ready for production. So in other words, you cannot today submit a support request to the Azure support, but this is something that will probably be coming with 0.3 version. When it comes to existing limitations, even in this new version, you still can't use copy function to use loops and generate more resources based on that, and conditional deployments using condition property. One more thing is also the single line objects and arrays, meaning that you need to actually stretch them into multiple lines, one array member, for instance, on each line. But apart from that, there are so many exciting new things. And when I checked, if you were following this project on GitHub, because the whole project, its backlog, the code base, of course, and the roadmap, everything is published on GitHub, and you are more than welcome to contribute. If you were following the progress and the plan, there was a feature scheduled for V3, which was called a decompiler, allowing you to take your existing ARM.json template and compile it back to Bicep. But surprisingly, this feature was actually released already in this .2 version. So we will actually begin with looking at it because this can help you with taking your existing code and looking at how does it look in Bicep. Switch to a really nice web tool. So in case you don't want to install any tool yet on your machine, the Bicep Playground is a great way to start. So it comes with 2 panes. One is, of course, the Bicep code. One is ARM.json. And you can start with, there is a number of samples that are part of the GitHub repo. So if we take the VM simple windows, you can immediately see on the left how the Bicep code look like, and on the right how does it translate or compile to the ARM.json. So the nice thing is, of course, that you can start adding new things. So I want to add a new parameter. And as you can see, this tool is actually telling you compilation failed because you need to complete writing that specific block of code. So some param and string, and when I complete that, it should compile well, and the new parameter would be simply added. So in this way, you can take those existing samples. But what is also quite useful is that you can take your existing template and actually decompile. So if I check, let me see which one it is. So that was something I wanted to show as well. If your existing ARM.json file includes some of those properties that are not supported, in this case, is actually complaining about nested templates. It won't decompile for you. So let's take something more simpler. So I took my existing ARM template I was creating for one demo, and now I can see how it looks in Bicep, and I can just take that code and refine it and forget about the JSON, and I will be able to compile it using the CLI. And after it is compiled to ARM, you can use any additional tools that you're used to for testing and validating and deployment. So it behaves in exactly the same way. So that's Bicep Playground. I highly recommend you to just look at it and see for yourself how this look. And of course, you can even start from blank and start typing, but it has support for sort of code coloring, but it doesn't give you any Intellisense. So I wouldn't use it as a primary tool. We will definitely switch to VS Code shortly, and you will see how different the experience is. So Still, if you don't want to install anything on your box, you've probably heard about Azure Cloud Shell. This one can be used to sort of play with Bicep as well. Since we are in this experimental phase with the Bicep binary, it is not included in the image that is supporting your Cloud Shell. So you need to install it yourself. And just to word of caution, you cannot really, since you are limited with permissions, you cannot add it to the path. So the only way how you can add it is to install it somewhere else. And I will show you how this was done. So David install that. So this is a simple script, and I would like to call out Chris and his great bill59s.com website, where he's publishing a lot of great articles about Azure. So this simple script allows you to install a Bicep on the side in some directory, and then you would be able to call it and use it to compile or decompile. But yeah, so it is. You can use this rudimentary code editor or any other built-in code editor if you're a Vim expert and similar. But again, the primary user experience is tailored around Visual Studio Code. So I would like to switch to this one. It's interesting how my otherwise powerful device is now extremely slow due to the broadcast, but I hope it won't crash on me. Come on. Okay, now it's working. Perfect. So there are two components that you need to install in order to start using Bicep. It's a Bicep binary. Of course, it is cross-platform and open sourced, and you can get it from the deployments artifacts from GitHub. And the second is extension for VS Code, and that one is also available in the same repo. So the product team has published a really nice guide on how to install it depending on what what operating system you use, and how to install the extension from the marketplace. If you use some previous version, you need to uninstall it first, because that one had to be installed manually using a file. Great. So I've installed all the tools on my machine already. So I can just check that I have Bicep installed. Yes, it is. There is a really nice tutorial with animated GIFs showing you some of the capabilities around Intellisense, around code completion, some basic set of snippets, as well as code navigation. So anything that you're used to, peak definition, find all references, everything is working in the same way as for other languages. But I think the most powerful thing is if we really want to start from scratch, even though I have a lot of examples. Bicep. If you want to start from scratch, it will give you a lot of leverage just by sort of hitting control space and sort of getting what should be the next block of code in your syntax. So obviously, Bicep supports comments, both single and multi-lines. So this is just params. So if you type a keyword, you can now have several options. So I'll just use this one, and you can say, let's say location space and it's string. This could be enough. If you want to extend it with some default value, you can say Norway, and that's fine too. If you want to extend it a bit more, then you actually need to provide more than that. But here I can just hit Control Space, and I don't need to remember how these things are called in Bicep comparing to ARM, where the names of those properties were, of course, a bit different. So allowed, yeah, this could be obviously an array. So I can say Norway East and Norway West. These are the local regions. What I sort of realized while trying to write the Bicep code from the beginning, I was doing a lot of mistakes by adding the commas, because you're used to do that when you're working with JSON. So that's nice. If we switch for a second and look at the declaration, and this is basically a copy from the repo. So you can see you have a full power of what types, data types you have available for parameters, for variables, and the definition is really sort of nice and clean in that sense. So, and of course, if you want to run and say I want to compile, so you can hit Bicep. And by the way, if you're seeing this, I hope you are. This is a new AZ predictor. It's a really nice new feature for PowerShell, where it can show you not only the history, but based on what commandlets for Azure modules you're using, it can actually predict what would be the logical next step. So it's powered by some artificial intelligence. So I can say not really decompile, and I say declarations. But of course, I would need to be in the right folder. Okay. Arguments. Oh, sorry. Yeah, you're compiling, but the right keyword is actually built, right? Not build. So hopefully this time it will produce the right. No, it didn't. Perfect. So that's something that you will get when you try to run that command. But the Intellisense in that extension is actually showing you some of these warnings and error already. So first you can see that I have two objects, or there is one parameter and one variable, and they both have the same name. In ARM.json, this wouldn't be a problem, right? Because you always prepend it with the function. It's either parameters or variables. In Bicep, you actually need to make sure that those sort of logical names that you have for each sort of code block are unique. So I need to change the name and make sure that it is unique. So that's the first one. Then it actually tells me that I don't have any endpoint property in DNS zone resource. So it's not just giving you hints about any syntax errors, but it also can cleverly check if that kind of declaration makes sense, or that kind of expression makes sense. So I can't really use endpoint. I would need to change it to something else, like zone type, for instance. That should work fine now. And then, of course, you can see here that there is, it's another example from the docs. So there is no example resource provider. So obviously that one wouldn't compile. So I can change it to something else. And there is typically a lot of questions around, will Bicep support new changes coming in ARM and resource providers, and how frequently will it get updated? Well, the thing is, it's a transparent abstraction. So even if you're running some older version of the Bicep CLI, and you put some sort of really brand new version of the API as part of the resource declaration, because that's how it's structured. It will warn you, but it will actually compile it. So if you, for instance, have an access to some private preview, an API that maybe the language server is not aware of, it will still allow you to compile it and deploy if that would be valid for your environment. Okay, so that was a simple explanation of some of the key syntax for parameters, for variables, resources, and outputs. So again, much cleaner, much simpler. The power of using or referring to properties with dot that is well known in other programming languages. It's extremely useful. If you compare it to a standard expression, you would need to come up with to define such outcome. So as I said, once you have your code compiled to ARM.json, you can use any tool that you're used to work with it. So I would like to move on a bit. Yeah, we went to this one. We set up our environment. So this is an example of a workflow I sort of adopted while working with Bicep. So I first author my Bicep code in VS Code, then I compile it, then I validate the template using ARM test toolkit. Eventually, if I want to, I can use this really cool extension called ARM Viewer. And I can actually continue with my validation and run the WhatIf deployment or run a deployment with WhatIf. So I can see the difference between the state in Azure comparing to the code I actually work with, and eventually use AZCLI to deploy to some test environment. So in my workflow, what I did, let's say use this one as an example. I have a simple, it's really slow. I have a simple Bicep file for creating a network interface card. So of course I could start typing those commands in the built-in terminal. But what I thought would be really nice is to use built-in tasks. So if you're not familiar with VS Code tasks, so you can run a task, and then I have defined these 4 tasks. So first I will do Bicep build, and it should actually build my code to ARM. And it did. If I want to, I can also look at it through the ARM viewer. If this happens to launch. Okay, it's not really interesting. And even as I can see, the label is somewhat corrupted, but it's a single resource, so it won't give you much of a value. But the next step would be to run next task, which is tested with ARM test toolkit. If you're not familiar with that tool, it's a custom PowerShell module, and it's using Pasta, which is a great test framework for PowerShell. So it should, based on the sort of predefined set of tests, give you some output about the health, and if you're following the best some recommended practices for authoring your ARM templates. So as you can see, it's complaining about the hard-coded location. So if I change that in the Bicep, recompile, and then I would run this again, this would result in much cleaner syntax. And of course, the last one I could actually use is WhatIf deployment. While it is running, I'll just show you how I created those tasks in VS Code. So it's a simple task.json file that you can have in every repo in VS Code, .VS Code directory. And it's a definition where you're declaring what should be running, what arguments, etc. So now we can see that my WhatIf is getting the status, because ARM.json don't use any state file, unlike Terraform, for instance. And you can see that the result of this test or WhatIf is that, okay, I will deploy one new resource to that defined resource group, and one is ignored, meaning that there won't be any change. Fantastic. So all that code, of course, I will share on my GitHub repo. But I thought this was an easy and a nice way how I can, and of course I could attach some code binding to those tasks, so I could simply have that workflow in a sort of semi-automated fashion. So when I'm happy with what I produced, then I could probably step up and take it forward with more advanced scenario and use some automation, for instance, GitHub Actions or GitHub Workflows. But before I do that, I wanted to call out that great new capability that is using modules. So module is, let me find the right example. Module is like any other Bicep file. It doesn't have any special syntax, so you can include the declarations of parameters, variables, resources, and outputs. And then if you want to use it, no, that's not this one. Declaration. If you want to use it, what you would do is you would simply use a keyword module, give it some name, and then provide a path to it's a relative path to the file system where you have that module located. Then it has some body where you can you have to define a name. That name will actually be used as a nested deployment name, and then you can or should provide any parameters that were declared in that module, and maybe pass through those from this main template declared parameters and variables. So that's how you sort of connect those. You can have as many modules in this main file as you like. You can even refer one module from another module. But what happens in sort of in the end as a result, when you build using Bicep CLI, it will produce one deployment file with several nested deployments. So if you're familiar with linked and nested deployments are those that have actually embedded the entire template inside the main template. It's not referring to some external endpoint where you can find the code. So and one module equals one nested deployment. But of course, one module can contain as many resource declarations as you like. So that's how it would look like when you compile it. So that's a capability that is native to Bicep. I would also like to call out a second option, which I also find quite interesting, and it's a possibility to use TemplateSpec, which is yet another new feature in the ARM sort of language family, if you will. Allowing you to store your templates directly in Azure, meaning that you will be able to refer to those templates like it was any other resource using its resource ID. So this is an example of using such deployment. If I just can highlight that variable storage template link ID is I'm using resource ID function, and I'm using, since that my template spec, this particular one is stored in another resource group than where I'm deploying to. I need to sort of refer that one as well. It's the resource type is TemplateSpec versions, and then I'm just adding the spec name and version number. So in this way, I could also reuse the code that I have built in using TemplateSpec. But of course, then the deployment of those TemplateSpec to Azure is happening in a different workflow. It's not part of this one. So just to show you how it looks like, in Azure you have TemplateSpec and you have main template. It also can have nested templates. So TemplateSpecs are a really interesting way how you can share your code base across teams, for instance. All you need in order to sort of refer to this TemplateSpec is to have a reader access to the resource group where it was deployed. So that's it's not really directly related to Bicep, but I like the fact that you can combine these two and maybe leverage some of the new things coming to Azure Resource Manager. Template specs are in public preview, if I remember right. So the last part, I would just like to show you how you can automate this workflow using GitHub Workflows. So what I did is there is so many great articles and great content provided by the community. So I would like to call out Sebastian Graf. I probably pronounce his name incorrectly. He wrote an article about GitHub Actions for Project Bicep. So he created a custom action. Actually, there are two. So you can simply, of course, you can view the source code and inspect what it does, but more importantly, you can easily start consuming it. So in my YAML file for the workflow, I'm just checking out my code base. I'm logging into Azure, not using the Azure provided AZ login, but that's also Sebastian's action. And then I'm using the deploy using Bicep. So this action will first compile the Bicep file into ARM, and then it will also deploy it to a defined resource group and location. So just to show you how this looks like in my repo, and I must admit that I've been playing with it quite recently, and I don't think I managed to get it deployed end to end due to some small mistake. But it's an interesting way how you can sort of automate the deployment. yeah, so there is some error I will need to work with, but feel free to create your own custom actions or just fork Sebastian's and maybe improve it and send him pull request. I believe he would appreciate it. So when it comes to the roadmap, just to close a bit. So code reuse, we talked about both modules and template specs. For the deployment using GitHub Workflows, I will provide a full reference to the article that Sebastian wrote. And if we now look ahead and see what's coming, you can check the roadmap yourself using the projects in that Bicep repo on GitHub. But what is planned to come, hopefully January, February, is first of all, you are getting, they are planning to complete the parity with ARM templates. So everything that can be done using ARM JSON language should be possible in Bicep. They will complete the gap that is very much used, and this is loops or copy function and conditional deployments using conditions. And then a possibility to deploy Bicep files directly from Azure CLI or PowerShell. And last but not least, it will probably reach like a support status by customer support services from Azure, meaning that it will be ready for production usage, and you will be able to create support requests if you run into any issues. So I think I would like to just provide the link to the repo, and of course I would encourage you to follow Bicep Lang on Twitter, so you will get any updates, what's coming, and they also publish events, community sessions that are streamed online. So that's a great way how you can meet other community members and hear directly from Alex Frankel and his team about the development of this great and interesting project. Okay, I think that's all from my side.
All right, thanks a lot. We're kind of short on time, so I just have one question for you. You showed a custom GitHub action that can deploy the Bicep file directly to Azure. Will we see dedicated tasks for that for Azure DevOps pipelines as well?
Yeah, so that's also something I probably forgot to mention. As of now, since the project is in this sort of early stage still, there is no like a official Microsoft provided GitHub action or Azure DevOps task or Azure pipeline task that would be coming from Microsoft. But if you sort of look into what needs to be available in either in the GitHub runner or in pipeline agent in order to compile and deploy, it is really not much that you're missing. You just need to make sure that you download that Bicep CLI, depending on what agent you're planning to use, and then make sure that it can execute the compilation, and then you would use a regular AGCL, which is baked into to those, at least in Azure DevOps, it's baked into the agent and deploy.
Okay, awesome. One more thing I wanted to say, knowing which outputs you have available is awesome. Instead of having to look them up in the documentation everywhere. So thanks a lot.
Thank you, it was my pleasure, and thank you for the opportunity to talk on this in this great event.